In our last review video for calculus, we're going to be talking about exponential and logarithmic functions. Again, like with the trigonometric video, I can start by explaining what exponents are, the rules of them, what logarithms are, the rules of those. But I'm just going to dive right into the function aspect because that's what's needed for calculus. And we're going to start off by talking about e. E is, well, a letter, that's obvious, but e is a constant called Euler's constant, and it basically is kind of like the exponential constant. It's like the main one, and it's approximately equal to 2.718. And e is sort of like the magical base for exponents. E to the power of x is a very common function, and it has a lot of interesting properties, especially in calculus. As you'll see later on, its derivative is itself. At this point in calculus, you probably don't even know what derivative means, but don't worry. Soon, when we talk about derivatives of exponential and logarithmic functions, I'll make sure to come back to this point, e to the power of x. And the way the graph sort of looks like is like this. The locator point is 0, 1 right here, and it goes on upwards. If you have like different variations, different transformations like we talked about, we just went over a brief review of transformations in the previous videos, but if you want like more about transformations, watch the pre-calculus videos about transformations. But back to this. If this is exponential, what's logarithmic? Well, like e, there's a similar magical base, and well, the base is e, but it's called something else. It's called the natural logarithm. It's NL technically if you're picky, but it's called LN because it's a different language. LN is for natural logarithm. Ln of x is basically equal to the logarithm base e of x. No one basically ever writes the last format. It's usually written as ln x. And how does the graph of it look like? So let me get rid of this and I'll show you. It's basically the inverse of the exponential function. It looks like this. If you were to rotate it a bit, you'd see that it is actually the exponential function, but it looks like it's on a different axis. So this is how ln x looks like, and its locator point is 1, 0, unlike 0, 1, but of course there are transformations that change it. So those are the main two functions, exponential and logarithm, but I wanted to go over something new, perhaps. It's called hyperbolic functions, and these are a variation of exponential functions, sort of, but it's not called exponential. Instead, it's called hyperbolic because it has to do with a little bit of trigonometry, and obviously, it looks trigonometric because it's called sine h. The h stands for hyperbolic, so sine h is actually a function. It's called the hyperbolic, one of the hyperbolic functions, and it's equal to e to the power of x. Remember, e keeps on appearing, minus e to the power of negative x over 2. Similarly, there's cosine h. I know it's tempting to call it cosh x, but it's called cosine h, or hyperbolic cosine, and it's similar. It's e to the power of x plus e to the power of negative x over 2. And I won't go into why it's called this. It's a bit advanced, but the graphs of it look very, very different from each other, and different from the trigonometric functions as well. Sine x, or sine hyperbolic of x, looks a bit like this. Cosine hyperbolic of x looks like this. And that's basically what hyperbolic functions are. It's probably the first time you've heard of it. So what's pretty important is the graphs of them and the equations of them. And it would crop up in calculus a bit, just a little bit though, not that much, not as much as other exponential and logarithmic functions. So today's video was pretty short. Didn't really require much explanation because exponential and logarithmic are pretty known already. It was just the graphs of them that I wanted to talk about and hyperbolic functions. So I hope you like these review videos. In the next video, we're going to actually get right into calculus and start working on limits. So thanks for this video. I'll see you next time.